Hello and welcome to this video where we will explain High Performance Liquid Chromatography, or HPLC, an analytical method used to separate, identify and quantify chemical compounds in a sample. HPLC is performed in the liquid phase, which means that solid samples need to be dissolved in an appropriate solvent before testing. The presence of even a small number of solid particles can cause blockages in the column. For this reason, the solution should be filtered with a microfilter before injection. Solvents, including water, must be of high HPLC purity to minimize contamination and possible effects on the results. Let's take a look at the device itself. Solvents, or elements, are placed on top of the device. The pump then pumps them through a degasser, removing air gases from the solvents as they flow to the HPLC pump, which then mixes them in a desired ratio. Samples should be placed in the autosampler. The autosampler can hold up to 100 vials at a time. After the sample is injected into the mobile phase by the injection needle, it will pass through the column. Finally, after the column there's a detector, T. This setup is equipped with a diode array detector, or DHD. Using a beam of light that spans the full ultraviolet and visible light spectrum, the DHD scans the samples and measures the absorption of each wavelength of light against the elution time of each chemical species from the column. When starting a measurement, you must apply a method. A method refers to all the parameters that can be programmed within the software. These include the solvent composition and gradient, the flow rate, and the injection volume. The injection volume depends on the concentration of the sample, but is usually between 2 and 5 microliters. Solvent composition and gradient have the biggest effect on the successfulness of the separations. Users are advised to search in literature for methods that have been used for similar systems in order to minimize the time needed for method development. An HPLC chromatogram is a graphical representation of the separation of a mixture of compounds during HPLC analysis. It shows how the different components in the sample are separated and eluted from the column over time. The horizontal axis of the chromatogram represents time, while the vertical axis represents the amount of each component in the sample. Each peak on the chromatogram represents a different compound, and the area under each peak on the chromatogram is proportional to the amount of the corresponding compound in the sample. The earlier a peak appears on the chromatogram, the faster it is eluted from the column. The time it took a compound to pass through the column is called the retention time. In order to obtain quantitative data from the chromatogram, the area under the peak from the analyzed sample can be compared to a previously constructed calibration curve. This concludes the video on HPLC. I hope you liked it and learned something new.